While modern medicine is capable of dramatic results, there still remains problems with side effects. What's wrong with the medicine?
Wouldn't it be great if you didn't have to take medicine every day, like a pill or a self-injection? Wouldn't it be great if that medicine you took didn't cause side effects? And wouldn't it be great if that medicine was produced naturally in your own body? And then, wouldn't it be great if you could then produce that medicine where and when you needed to? Well, we have a concept that can help bring that to reality.
To bring this to reality, we will use an amazing tool developed by science. It's called optogenetics. Say you go to the doctor because you have joint pain caused by arthritis. The doctor will give you one shot of light-inducible therapeutic gene and send you home with an LED wrap. Applying the LED wrap is very easy. You don't actually feel the light. A typical treatment will take 5 minutes twice a day. The light will activate a therapeutic gene and produce a therapeutic protein. The therapeutic protein will reduce inflammation and pain. It will happen locally without poisoning the body with drugs. Well, it sounds like science fiction, doesn't it? Star Trek fans wouldn't be at all surprised if light was activating DNA. But can this be done for real? All we need is for the light to penetrate deep enough, activate DNA sequence, and produce a therapeutic protein. So how deep does the light go? This we know very well. Low-level laser therapy has been around since the 80s. It uses cold lasers to treat arthritis, pain, inflammation, wounds, migraine, and other disorders. Here, I put my hand over an FDA-approved LED array, and you can see that the light goes through my hand, which is over 3 centimeters thick. So yes, light can penetrate pretty deep, enough to treat many health problems. DNA sequences activated by light have been known for many years. They are called light-inducible promoters. We also have done an experiment where we screened 20,000 human DNA sequences. This is our experimental setup for light delivery. Human cells are irradiated here. In this experiment, we identified new candidate light-inducible promoters. Optogenetic tools allow scientists to activate genes in human cells. Here, Duke University scientists programmed cells to respond to light by making green fluorescent protein. They used a laser to draw a smiley face on a layer of human cells. This activation is reversible and repeatable. So, all 3 components are already working in the lab. The light activates a promoter, which activates a transgene, which in turn makes a protein. Use of genes to make therapeutic proteins in the body is called gene therapy. In the last 25 years, many thousands of patients received gene therapy in many hundreds of clinical trials. Many patients have been wonderfully cured. Here you see first 2 gene therapy patients in 1992, and recently, 22 years later, they were cured from a deadly genetic disease. This is Yannick Dewey, who was cured from blindness in 2008, and now he advocates for gene therapy on a medical conference. Many hundreds clinical trials are done by now. Even more, some gene therapy treatments are approved for commercial use in Europe and Asia. In China, gene therapy was approved early 8 years ago, in part because it is more affordable than making same therapeutic proteins in a factory. The therapeutic proteins made in a factory are called biologics and are very popular in the West, although expensive. A typical biologic costs over $20,000 a year to a patient. Gene therapy makes these biologics inside the body. Yet, conventional gene therapy doesn't use light, so there is no control where and when it works. So the effects are systemic, and currently there is no way to control what happens once a drug is inside the body. This is why gene therapy progress is slow. We believe our solution will make gene therapy perfect. I'm Max Makishev-Rempel. My research has been always focused on DNA and light. My papers and patents have been cited over 2,000 times. I have done my master's on DNA synthesis 30 years ago. I became fascinated with the Human Genome Project 25 years ago when Jim Watson, the one of the double helix, visited our institute in Moscow. My PhD work was a part of Human Genome Project. That is where I first experimented with lasers while attempting to make my version of a fluorescent DNA sequencer. That was 20 years ago. My most cited work is in genetics of schizophrenia. In this team, I was setting up fluorescent DNA sequencers and genotyping robotics. We were first to positionally identify a gene for schizophrenia. 6 years ago, I registered a company, Healing Photonics, and applied for a grant to activate genes with lasers. A review came back saying remote control of specific gene expression is a science fiction ideal. Nonetheless, we got a tiny bit of funding plus added our own money to study the effects of red light on mice with cancer tumors. We found that it was reasonably safe. My largest funded study was the first animal study of light-inducible gene therapy. We made much progress, but the funding has dried up. So, I registered a new company, Localized Therapeutics, to be able to apply for small business grants and continue the research. We are not yet funded, and therefore we are fully independent. In 2 years, we have submitted 7 grant applications. The reviews were quite positive. They said that it is innovative, represents a paradigm shift, and is likely to work. They said that this would be a significant advance for the field, a great benefit to the neuroscience, and the list of applications must be huge. They said that our team is capable to accomplish the task, that we have an excellent track record, extensive experience, and are uniquely qualified. I have a wonderful team of collaborators who are ready to continue as soon as we get funded. We need your help to make more data and to demonstrate to our funders that the approach is feasible. My collaborator, Dr. Ray Lanzafam, is a surgeon and an expert in light therapy respected worldwide. My collaborator, Dr. Stadler, started his research into laser therapy over 30 years ago with its inventor, Dr. Mester, and he is eager to participate in the project. And we will continue to engage undergraduate students in our research. We will combine our knowledge of lasers and genes to create light-inducible gene therapy. We believe we can do it. We know what needs to be done, just help us to get it going. Many people, funds and investors said that they would help us once we get moving. So we ask you, the people, please realize what is good for humanity and give us your support. Contribute now, let's make this happen. We don't hide behind closed doors. We don't speak a cryptic language. We come to you as close as possible. We speak to you directly. We will keep you updated. We will discuss the results publicly. Together, we can manifest this into reality. This is not rocket science. It is DNA, and we know DNA inside out. You shine a light when needed and where needed, and the DNA will do the rest. Support us now, let's make it happen. It is the future. It is revolutionary. The medicine can become healthy. Finally, you would start feeling good about it. We are on a mission and need your help to kickstart this avalanche. Support us now.